Let's look at number 2. We have to use a calculator for this. Have to. If we don't use a calculator, you're really going to struggle. So we're given a velocity function for a particle. This is a velocity function. It's not a position function. Question is, find all the values of t in the interval for which the speed of the particle is 2. Okay? We know speed to be the absolute value of velocity. Well, speed being 2 means I'm figuring out when my velocity is equal to 2 or negative 2. Now, that's it. I need to figure out when my velocity is 2 or negative 2. I don't need my acceleration function. I don't need anything crazy. I just need to figure out when this negative 2 plus t squared plus 3t to the 6/5 minus t cubed equals 2 or negative 2. Now, you want to try to solve that by hand? No. You have a calculator. So here's how we would figure this out with our calculator. It's the simplest thing in the world. You were never taught this in algebra class or in any other class because it would just be all you would do to solve any type of equation. If you want to solve any equation, you graph the left side, you graph the right side, and you see where they intersect. It's that simple. You could have done this since day 1 in high school, but everybody doesn't like to teach it this way because it's like cheating. I want you to do some work. So I plug in the left side. Then I plug in the right side. Let's start with just 2. And I can do it all at once, but let's keep it simple. Actually, I'll do it all at once just so I can show you how you can look at both of them. And we graph them. And we're looking between 2 and 4. So like this is the graph of V. But I'm really just looking between 2 and 4. So right here to here. I need to figure out when these graphs intersect. How to figure that out? Second, calculate your intersection. And we can scroll our first curve over to our first intersection right here. We'll press enter. We will make sure the correct second graph is selected. This is y equals 2. If I press down, notice I would bounce to the third line, y equals negative 2. So I want to be with the first one and y equals 2 to find this first intersection. That is when t is equal to 3.127 or 3.128. Now we do it with the second one. Now we need to be between 2 and 4. So the second intersection, second calc intersect, between 2 and 4 would look to be right here because we're still between 2 and 4. There is another intersection right here, but that's not between 2 and 4. So I select my first line. Now I need to select the y equals negative 2. So I would move down, press the down button to get to y equals negative 2. Enter, enter, enter. I think I pressed enter too many times. Second calc intersect. Enter, make sure we're at negative 2. Enter, guess, enter. There we go. 3.473. Okay? That's it. Those are your 2 times when the speed is equal to 2. Now let's look at part C. Find the times in the interval from 0 to 5 in which the particle changes direction. Now, we talked about moving to the left. We talked about moving to the right. Ms. Kordzik, if I'm moving to the left, what is going on? Beautiful. If I'm moving to the left, the velocity is negative. If I'm moving to the right, then the velocity must be positive. So when I'm changing direction is when I switch signs for my velocity. When my velocity changes from positive to negative or from negative to positive. On your graph, go ahead and let's get rid of the 2's. All we need to do is see when my velocity changes signs from positive to negative or negative to positive. Or we're looking at when we could have zeros. So these are positive velocities up here. Here are negative velocities. Here are zeros here and here. Now, 2 ways to calculate 0. I like just to graph the line y equals 0. Also, I like to change my window so that I'm looking at the interval specifically. I usually like to start 1 to the left of my interval and then go to 1 to the right. So I'll go from -1 to 6. Seeing I have one situation right here, this is where we're going to be changing directions. And then right here, we're going to be changing directions because this is the graph of velocity. We go from negatives to positives to negatives. So second calc intersect. I will find this first 0. Right around here, enter. My second curve, I already graphed the line y equals 0. Make sure you graph that. Guess. Here's one location. T equals 0.536. Second location would be over here. Second calc intersect. Pop over to what looks like 3.1 or something. .3, enter, 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 3.317. You'd have to be this accurate with your answers. You cannot just use trace and say, oh, around 3.3. You're going to be accurate to, I think, the third decimal place. I forgot which decimal place I have to show. It's either 3 or 4. Okay? So that's how you'd use your calculator to find certain information, to see when a particle is changing directions. You could also look at the graph of velocity to see if your acceleration is positive or negative. So if I was asked if my speed is decreasing at time 4, well, time 4, my velocity is negative. My acceleration, which is the derivative of my velocity curve, would also be negative. My speed would be increasing. Okay? All different stuff we can do with our calculator. Was there a part D, or is that it? Oh. Oh, look at that. Jeez. I just said it. Crazy. So, is the speed increasing or decreasing at time 4? We'll look at the value at 4. You could press trace, and then after you press trace, you can click on 4. You'd see that the velocity is negative. So you would say velocity at 4 is less than 0. And then you look at the graph of velocity to figure out that your acceleration, which is equal to the derivative of your velocity at 4, is also negative. So you would say the speed is increasing or decreasing? Increasing at t equals 4, and your justification, your reason would be because v of t and a of t have the same sign. At that location. And that would be included as like the proper justification statement you would need on a, speed increasing, speed decreasing statement. If you want to put that in your notes too. Speed is increasing if the signs are the same. Speed decreasing if the signs are opposite. All right, let's stop this video. That way